So there is one student who is brilliant and talented like you, okay, and these are the marks obtained by that student, okay, in these various subjects. In physics he obtained 85, chemistry 88, and these are percentage, right? So out of 100 all of these. See, maths, he's too good with maths, and I love students who love maths, right? So in maths he obtained 90 and so on, right? So you can read this table like this, right? And now you have to find out, they are asking you to find out arithmetic mean and weighted arithmetic mean. You would say now, ma'am, we know the concept of arithmetic mean, you have taught it in the previous lecture, but then what is weighted arithmetic mean? Okay, understand this concept logically. Okay, so these are the marks obtained by you in the 12th standard, right? And you are trying to apply for various graduations now, right? So when you plan to apply for BBA, for example, Bachelor in Business Administration, they would require what? They would require English a lot, correct? Communication has to be good when you go for BBA. They would say, okay, maths also needs to be good. English and maths will have the higher weightage. But if you plan to go to say BSc Micro or BSc Computers, then in that case they would say, okay, maths needs to be good, chemistry, physics also needs to be good, correct? And these languages can have like a lower priority, right? So these priorities or importance is nothing but the weightage, and that varies depending on which stream you are applying for. Getting my concept? Student is applying for BSc Computer Science, okay? And BSc weightages assigned to the subject for BSc Computer Science are like this. So physics, chemistry and maths will have 333, means much higher weightage than these languages, right? In languages also Hindi will have the higher weightage. They will have their own reasons for this, okay? So this is how you read the weights also, okay? So when the weights, constant weights are assigned, or when there is no any special importance or priorities for the data or within the data, in that case you don't have to look at this weight factor when it is constant for all the data, correct? But when the different weights are assigned to the different set of data, in that case you have to find out the weighted arithmetic mean. And how is it different than arithmetic mean? I'll tell you right away. Okay, so for this question, if you try to find out the arithmetic mean, it's quite easy. And then these marks are nothing but what? You can say it is as x, correct? There is no question of f or frequency in this case. So what's the total of this x? Whatever is the total of these marks divided by capital N. Capital N means number of observations. How many are there? 6 observations are there, and that will give you the arithmetic mean, correct? So what's this summation of x? This is 468. Yes. So arithmetic mean, x dash arithmetic mean is going to be what? This summation of x divided by the summation of x divided by n, total number of records. What's the summation of x? You just found out 468 divided by total 6 records are there, 78. So the arithmetic mean is 78 for this question, and the unit of this is going to be what? Percentage, because these values are given in percentage. Easy. Now let's move to the weighted arithmetic mean, because the different weightages are assigned to different subjects. Clear? For that, say this weightage is what? Small w. So to find out the, you need to find out the wx here, okay? W and x, multiplication of these two. The way you find out the fx, you remember when frequencies are given to you, correct? The same way you have to find out wx here. What's w? 3 into x is 85, right? So take the multiplication of all of these. When I took this wx, the individual value came as this, and when you take the total of this wx, 1064, okay? So this is x arithmetic mean and weighted for w. Small w stands for weighted arithmetic mean, okay? The formula is summation of this wx. The way we used to take summation of what? Fx, correct? Same way wx. Now there is no point of taking this n, right? Number of observations the way we used to take here, correct? Because this is all about the weightages, and that is why in the denominator you are going to take the summation of w. Okay, which means that you have to find out this summation also. So what's the summation of this w? Easy, 13, correct? Basically you are going to do this 1064 divided by this 13 and 81.85. So this is your weighted arithmetic mean. This is your weighted arithmetic mean, which is also expressed in percentage, because everything is about the percentage of the students obtained by a particular student, correct? So this is the basic difference between the arithmetic mean and weighted arithmetic mean. I hope you understood the concept, when to apply the weighted arithmetic mean formula and how that formula looks like. Okay, keep studying, keep practicing, and if you have any doubts, please ask me in the comment section. I'll try to revert you. Share this video with your friends and like, share and subscribe to my channel if you like this video. See you in the next video. Bye bye.